Welcome to the Deep Dive, your shortcut to being well-informed. Today we're diving deep into something that, well, it underpins pretty much every building around us, but you probably never even notice it. Okay, let's unpack this. Picture yourself in, say, a brand new office building, or maybe just your own kitchen after a renovation. You're surrounded by stuff, right? The paint, the steel beams, the tiles, the heating system humming away. Did you ever stop and think, how did these specific things get chosen? Out of thousands of options, who decides exactly what goes where and, how well it needs to work? It's a question we almost never ask, but the answer is, well, it's fundamental to making sure buildings are safe, last a long time, and actually do what they're supposed to do. Today, we're pulling back the curtain on one of the most vital yet seriously unsung roles in construction, the specification writer, or, the specifier. These folks are the architects of detail, the unsung heroes making sure big design ideas become real, buildable things. Our deep dive mission today, to explore their world. We'll trace how construction specifications evolved, why they're so incredibly important, and how these documents basically form the legal nuts and bolts of any building project. You're about to find out that a building isn't just designed, it's specified.
And that's absolutely the key point. It's so easy to just see a building as, one whole thing, a solid structure. But when you really start to peel back the layers, it's fascinating. Every modern building is this incredibly complex assembly. We're talking countless individual parts, specialized systems, different materials, all needing to work together perfectly, like a huge, intricate machine, the kind of precision needed today. I mean, whether it's a skyscraper structure or a green building's energy efficiency or the systems inside a hospital, it would have been totally unimaginable, maybe just 100 years ago. And this isn't just about picking materials, it's really about defining quality from the get-go. This role, this meticulous defining of everything, it ties right into basic project management ideas. Think about build quality into processes and deliverables. This specifier embeds quality in the instructions. It's not an add-on. And tailor based on context, because every single project is different, right? Different site, different needs. The specs have to reflect that precisely. It's all about being proactive with quality.
That makes total sense. And this need to define things, it's not new, is it? It goes way back. But how did, say, ancient builders manage it? Pyramids, cathedrals. Now, they didn't have these huge manuals or digital files we use now. They must have had some way to specify details, even if it wasn't written down like today. We even see it in architectural philosophy, like Leon Battista Alberti back in the Renaissance. He wasn't just sketching things, he stressed needing a clear and distinct idea covering the number, extent, form, species, and quality of all the parts, how they are to be made, and by what artificers. You got it. Way back then, you needed exact instructions for everything, right down to the smallest detail. It was about getting everyone on the same page, mentally.
Exactly, and even earlier. Look at Vitruvius, the Roman architect. His writings specified things like column sizes, the details on the capitals. He might say a column should be 2 modules thick and 14 high. It's a very basic form of standardizing parts really early on. Now, connecting that to the bigger picture, these ancient specs were very different from modern ones. A lot relied on the master builder just knowing stuff, on skills passed down or traditions within a craft guild. You see hints of it in things like the stonemason's lodge from the 1400s, skilled workers sharing practices, or names carved into the Chartres labyrinth suggesting accountability. The details were often in the craft itself, in the builder's head or hands, or maybe in physical models. The master builder was the specification, in a sense. But, and this is key, as projects got bigger and way more complex, think moving from a small church to a massive cathedral and you had more specialized trades involved, well, just relying on memory or word of mouth or a simple drawing wasn't enough anymore. It got risky. Imagine coordinating hundreds of different workers, maybe each with their own terms for things, on one huge project. The potential for errors, delays, misunderstandings, it would have been massive. So this growing complexity, this explosion of different jobs on site, it created this huge need for clear written instructions that everyone could follow. No ambiguity. It wasn't enough to know it. You had to write it down.
Okay, and here's where it gets really interesting, because then things just took off, didn't they? The Industrial Revolution changed everything. New machines, yeah, but also totally new materials, new ways to build. Le Corbusier nailed it when he said, tools and techniques transformed all at once with an amazing rapidity. Suddenly, it wasn't just stone and wood. You had steel beams, reinforced concrete, all sorts of engineered wood. Think about the sheer variety. Standard lumber plus special woods like redwood or cedar needing different handling. And then came specialized insulation batt, extruded polystyrene with specific performance values. Plus, the really complex mechanical, electrical, plumbing systems, MEP, that are standard now. each one a whole world of its own. This explosion of choices, this massive menu of materials and methods, it absolutely demanded a much more detailed, structured way of doing things. You couldn't just say build a wall anymore. You had to simplify every single layer, the cladding, the barrier, the insulation, the structure, the finish. For a window, you'd need the glass type, the frame, the sealant, even the 2x10 treated wood bucket sits in, like our sources mention. Without that level of detail, it's just chaos waiting to happen. Mismatched parts, costly mistakes.
Exactly right. Without that structure, you're basically asking for trouble. It's like trying to assemble a complex machine, but everyone's calling the parts different names, using different measurements or different methods. You get what the tech world calls a heterogeneous set of object types, just a jumble. Different terms across projects, across regions, even within one company. It leads straight to mistakes, confusion, budget blowouts, delays. As one source puts it, the opportunities for error in interpreting these documents are numerous without clear standards. It's like trying to play a symphony with everyone reading different music, just noise.
And that's where this really crucial development comes in, bringing some order to the chaos. The Construction Specifications Institute's MasterFormat. CSI MasterFormat. Sounds maybe a bit dry, MasterFormat, but it's actually genius. It's not just a list, it's an organizing system, a standard structure for all this information. It gave the whole industry a common language, a way to classify everything. Think of it like the Dewey Decimal System, but for building parts. So let's take an example from the sources. You might see CSI MasterFormat 1235 30.23, bathroom casework. Now, to you or me, that's just numbers and words. But to everyone in the project, the architect, the specifier, the contractor, the supplier, those numbers mean something specific. 12 is furnishings. 35 is casework. 30 might be institutional type. 0.23 may be a specific material. It instantly tells them where to find all the details about those bathroom cabinets. This system organizes everything. Finish work 10.02, down to plaster, ceramic tile, wood flooring. MasterFormat basically created a universal dictionary for construction, vital for clear communication, making sure everyone's talking about the same thing. It really was a game changer.
It absolutely was.
Yeah.
And that push for standards for a common language, it's just getting stronger with digital tools taking over construction. Building Information Modeling, BIM, is a perfect example. BIM isn't just fancy 3D software. It's often misunderstood that way. It's actually, as one source calls it, a human activity that ultimately involves broad process changes in construction. It forces a standardized approach to how specs are handled throughout the project. You see, BIM needs things like object classification, naming conventions, and attribute structure for every single digital part in the model. What that means is a digital door isn't just a picture, it's an intelligent object. It knows its fire rating, who made it, the finish, the warranty info, the cost, and yeah, its master format number. This detailed, structured data is crucial. It lets BIM models talk seamlessly to other tools for things like cost estimation, system analysis, even checking against building code and building program assessment applications. Imagine automatically linking your model to cost databases or energy analysis software. It streamlines everything, cuts down errors, speeds things up. We even see ongoing efforts to refine this, like the Revit-Seek metadata style guide mentioned in the sources, basically, a draft spec for how BIM data itself should be structured. It's all about making information smarter and more connected.
Okay, so once you have these frameworks like MasterFormat and BIM providing the structure, the specifier then gets into the nitty-gritty of defining the actual components. And this is where they have these two main approaches, right? Prescriptive versus performance. It sounds like a really key strategic decision. Let's break that down. First, prescriptive specifications. What does that mean exactly?
Right. Prescriptive is just like it prescribes. It tells you exactly what to use or exactly how to do something. It might name a specific product, brand X window, model Y pump, or it dictates a very precise method. Install these layers in this exact order using these specific fasteners. Think of it like a very detailed recipe. You follow it precisely. Not much room for interpretation, and that's often the goal, control, and predictability.
Gotcha. And the sources gave examples like for a window installation, it might spell out using a specific polyethylene vapor barrier, a certain type and thickness of rigid insulation, extruded polystyrene, XPS, and even the 2x10 treated wood buck frame. Super specific. Or building codes often have prescriptive bits, right? Like mandating naturally durable woods or pressure-treated woods in damp areas, not just saying use rot-resistant wood. Or needing wood panels to meet exact standards like DOC PS1 or PS2, even down to the thickness of concrete slabs, like 34:1 minimum thickness. So it's basically use this, do it this way.
Exactly. Now, contrast that with performance specifications. Here, the whole focus shifts. Instead of dictating the what or how, performance specs define the result. They define how a product must perform or the desired outcome. What's really interesting here is it leaves the how or the what up to the contractor or supplier as long as they meet the performance target. It's like saying, I need a wall assembly that achieves a 2-hour fire rating
Yeah.
rather than listing every single stud, board, and screw type.
Ah, okay. So it's more about the end goal.
Precisely. It encourages innovation. For example, instead of naming a specific fire door, the spec just requires a certain required assembly rating for the wall. The contractor can then propose any system that meets that rating. Or, for glass, it might say it needs markings to show which criteria the material was tested for, meaning it has to meet standards for, say, impact resistance, but maybe different types of glass could achieve that. This is huge in green building. Specs might demand insulation and vapor barriers achieve a certain effectiveness and energy-saving value, pushing for better energy performance without locking into one product. You even see performance-based design contracts used specifically to encourage sustainable design features like lower energy use. It empowers the industry to find the best way to meet the goal.
So it's a real strategic choice for the specifier then, deciding which approach to take. Because prescriptive gives you that control. You know exactly what you're getting. Consistent, predictable. But I guess the downside could be, well, does it limit innovation? If there's a newer, better, maybe cheaper material out there, a prescriptive spec might rule it out. Could it drive up costs sometimes?
That's the core tension, absolutely. Prescriptive gives you certainty. Great for consistency, especially if you're building multiple identical units or need a very specific look. It also simplifies bidding in one way everyone prices the exact same item. But yes, the drawbacks are real. It can stifle innovation. If a manufacturer develops something better or cheaper that does the same job, it might be excluded. And yes, it can increase costs if that specific product is hard to get, expensive, or needs specialized labor that isn't common.
Okay, so performance specs sound like the answer then. More flexibility, encourages new ideas, potentially lower costs.
Yeah.
They definitely offer that flexibility and can spur innovation. Contractors can propose solutions that are more cost-effective or use newer tech as long as they hit the performance target. Think about those vapor retarder examples. You could have foil-faced bats, a separate plastic sheet, or even special paint. Each has different costs and installation needs. A performance spec lets the contractor choose the best method for the situation, but critically, it also transfers responsibility for meeting that performance target to them. They own the outcome. This can lead to great value, but, and this is a big but, it requires really careful verification. You have to be sure the chosen solution actually does perform as needed. It shifts risk and requires more robust quality assurance during construction.
That makes sense. It's not just about picking one. It's about which approach fits the project's goals and risks best.
Exactly. And sustainability goals often drive performance specs, requiring recyclable and recycled content materials or weighting post-consumer content higher for lead points. That's performance-based. You're not saying use this specific recycled carpet. You're saying your carpet must meet this recycled content percentage. It pushes the whole market to improve. It's a powerful tool, but needs careful management. It's a real balancing act.
A balancing act, yeah. Which brings us right to the specifier themselves,
Yeah.
the person actually doing this balancing act, managing all this insane detail. It's clear this is way more than just typing up lists. They're this vital link, aren't they? Connecting the architect's big vision with what the contractor actually buys and builds. They have to translate these ideas, aesthetic, functional, into something practical, buildable, legally sound. It sounds like it needs a really unique mix of skills. What are we talking about here?
Oh, absolutely. It's a demanding role requiring a really diverse skill set. First off, you need deep technical knowledge, and I mean deep. Not just knowing what the materials are, but how they work, their limits, how they interact, the best way to install them. For example, understanding concrete's hydration reaction, how it cures. In hot weather, it cures too fast, potentially causing cracks. So a specifier might mandate using cool ingredients or even crushed ice in the mix to slow it down. That's real technical detail. Or knowing about wood movement, how it swells and shrinks with moisture. If you restrain wood when it swells, you get compression set, permanently damaging fibers, loosening joints later. That kind of detailed knowledge is crucial. And it's not just materials, it's construction methods, the sequence of work. Ensuring what Specify can actually be built, like knowing you can't pour a full-height concrete block wall all at once because of the pressure. You need to specify pour heights, curing times. Without that technical grounding, specs can be unbuildable or unsafe.
Okay, so deep technical chops. What else?
Next, Legal precision. This is non-negotiable. Specs aren't just guidelines, they are a legally enforceable part of the construction contract. They're often the bulk of the written documents defining the project. This means the language has to be incredibly precise. No ambiguity. It needs to align perfectly with bidding rules, contract terms. Think about it. If one sentence about floor tile finish can be read two ways, you're heading for disputes. Ambiguity leads to costly mistakes or claims by the contractor for extra time or money because their interpretation was reasonable but different. The specifier is, in effect, a legal wordsmith for construction. They turn technical needs into binding contract language, often preventing lawsuits before they even start.
Wow. Technical expert and legal eagle. That's quite a combo. Is there more?
Yes. Thirdly, meticulous organization. You're juggling information for potentially thousands of different products and systems in one building. This includes managing all the data in BIM models, the object classification, naming conventions, attribute structure, making sure every digital part has the right info attached. And this organization directly impacts costs. Specifiers review cost estimates against the specs because the specs often contain critical cost info not shown on drawings. Like, the drawing shows a wall, but the spec says it needs expensive fireproofing. Without that meticulous cross-referencing, budgets get blown. A missing detail in a spec or a BIM object could mean a huge change order later. It really is like managing a giant complex puzzle where every piece needs a perfect description.
A giant puzzle with legal and financial consequences if you lose a piece. It really sounds like they're the ultimate detail-oriented project managers. And this connects right back to those project management principles like effectively engage with stakeholders. They're constantly talking to architects, engineers, suppliers, contractors, balancing everyone's needs and recognize, evaluate, and respond to system interactions because they have to see how changing one thing impacts everything else. And when this doesn't happen properly, well, the examples you mentioned are pretty stark. Those projects needing extra clash detection because the BIM specs weren't detailed enough from the start. Or that hospital where lack of BIM requirements in the specs led to major coordination headaches with all the complex MEP systems later on. That's wasted time and money, directly linked back to the level of detail in the initial specifications.
Precisely. It highlights that specs aren't just a pre-construction checklist. They're a living document, crucial throughout. And their legal weight is immense. They are the second part of the contract documents, right alongside the drawings. That makes them the legal baseline for sorting out disagreements. Construction is complex. Interpretations can differ. A subcontractor might read the plans and specs differently than the GC. Clear, detailed specs are what define the exact scope of work, preventing arguments about who's responsible for what. And things like record drawings or as-built documentation, which are basically the final marked up specs and drawings showing what actually got built, they become the definitive legal record for the building's whole life, essential for maintenance, future changes, or if any issues arise years later.
So beyond legal protection, they're fundamentally about quality control, aren't they? Making sure the building is built right, exactly as intended, minimizing shortcuts or deviations, ensuring performance, and making sure it meets all the building codes, those minimum safety standards. Specs take those codes and turn them into specific actions. Code says glazing needs fire rating marks. The specifier details which marks, for which locations, and how to install it to get that rating. Code requires treated wood. The specifier lists the type of wood, the treatment standard, the fasteners needed for that specific application. They ensure not just minimum compliance, but real lasting quality and safety. They're the guardians of the building's quality.
Absolutely. And that ties directly into their role in risk management. Good specs are proactive risk management tools. By clearly defining everything upfront, outcomes, responsibilities, performance levels, they help optimize risk responses before problems even arise. This clarity prevents those dangerous omissions and discrepancies that lead to costly mistakes and expose everyone to risk. Think about enforcing contract clauses like liquidated damages for delays. How can you prove a delay or noncompliance if the specs weren't crystal clear about what had to be done and when? Ambiguity makes enforcement nearly impossible. Robust specs support good project governance and ensure quality is built in, not inspected in later. They are fundamental to reducing threats and keeping projects safe, on time, and on budget. They manage risk through meticulous detail.
It's just incredible. After diving into this, it's so clear how vital this role is. The reliability, the safety, the basic functioning of our buildings really rests on the shoulders of these specifiers and their meticulous work. So as we wrap up this deep dive, I really hope you, our listener, have a newfound appreciation for the specifier. We've gone from ancient notes to complex digital models, seeing how this role demands this incredible mix of technical skill, legal precision, and obsessive organization. Remember, Specifications aren't just lists. They're the legal and quality backbone of construction. So what does this mean for you? It means that the safety, the durability, the sheer usability of every building you walk into is directly shaped by the unseen work of these professionals. They are the indispensable weavers of detail, making sure the architect's dream becomes a solid, safe reality.
And looking ahead, this role, it's only going to get more complex, more critical. Think about the materials coming down the line: self-healing concrete, transparent wood, carbon capturing materials. Then add smart building systems, AI managing heating and cooling, predictive maintenance, environment that literally learn and adapt to occupants. And the push for sustainability is huge: net positive energy, circular economy principles where materials get reused over and over. Buildings are becoming part of this vast interconnected digital network. The line between physical and digital is blurring. So here's a thought to leave you with. How does the specifier's job change when buildings aren't just structures, but these complex, adaptive intelligence systems? What new kinds of specification will we need? We'll be specifying data protocols, ethical rules for the building's AI, how it interacts with the city's network, how it learns. It's moving beyond just specifying what it's made of to defining how it behaves and evolves over its entire life. Fascinating stuff to think about.